So, to solve an exponential equation in which the two sides cannot be written with the same base, then we're going to use this property right here. Logs can be used to solve exponential equations. So if it's exponential and you can write it as the same base, do so. Okay? But if not, we're going to review another property, if you remember from last class. Log base, usually that's a B. Log base b of b to the x. What is log base b of b?
X.
It just cancels. So anytime you have a log of the same base and an exponential of the same base, those cancel, and you're just left with the value that was the exponent of the exponential, x. Okay? So we're going to use that today to help us solve exponentials that cannot be rewritten with the same base. So starting on example 1, first of all, you always need to get the exponential by itself. That's always the first step. So what do I need to do to, if that whole left side is being divided by 2? The whole left side is being divided by 2. Multiply both sides by 2. So those cancel. We get 6 to the 2x minus 1 equals 36. So for this one, can you rewrite the bases the same? Yeah. What is 36 with a base of 6?
6 squared.
6 squared. Remember, yeah, it's 6 times 6, which is 6 squared. Now, you just set the exponents equal. So we get 2x minus 1 equals 2. And then we add 1 over. 2x equals 3. Divide by 2. That means x equals 3 halves, or 1.5. That's another review. If they can be written as the same, do it. Okay, now let's go to example B. First step, always get the exponential isolated by itself. So what do I need to do first? Subtract over the 1. That's never going to change. So we get 3 to the x equals 11. Now, can 11 be rewritten as the smaller base? 3 squared, 3 cubed, 3 to the 4. No. So, we're going to use this property over here. Log of what base will cancel that out? Log base 3. So I am going to log base 3 both sides. You can do anything you want to an equation as long as you do it to both sides. So log base 3 of 3 cancels. So now I'm left with x equals. Now for some reason everyone always forgets to log the right side. They cancel the left side and then they just say x is 11. I don't know why it is. With logs, we just forget. Like if you multiply both sides by 2, we're fine. Or if we add 1 to both sides we're usually fine. But for some reason, when we log, people forget to log the other side. So this is log base 3 of 11. Now on a multiple choice test, that might be your answer. Log base 3 of 11. But if not, if it's a short answer test, they'll probably tell you to round to like 4 decimal places. And this can go in your calculator, right? Can I use the log button for this? No, what's the base of this button? 10. But this one's 3, right? So we need to hit math up. And it's that one log base right there. So log base 3 of 11. And now let's go to 4 decimal places, so 2.1827, because the 5 comes after the 6. Okay, you can grab it. 2.1827 would be your final answer. All right. Let's go to example E. Example E. Is the exponential by itself? Yeah, it is. There's some extra stuff up in the exponent, but there's nothing around 7. There's no like 2 multiplied in front or a plus 1 in back. So I can go straight to logging both sides. And what do I need my log base to be? Log base 7. That's going to cancel out the exponential. You always pick the base that will cancel out the exponential. So those cancel. We're left with 3x minus 1 equals, now don't forget to log base 7, the right side, and sorry, that's a greater than or equal to sign. If we log both sides, the left side cancels, but you still have to log the right side. Do what? Did what?
To cancel out the...
Why did you just add log?
I didn't add log, I logged both sides. Log base 7 of 7 cancels. So I purposefully choose the log base that will cancel the base of the 7 using this property over here. Just like we did on the example above it. Do you get that one? This one's not any different. Yeah, the same thing. We log base, what did we do on B? We log base 3 both sides to cancel out the 3. Now we're log base 70 both sides to cancel out the 7. Okay. So now, what do we need to do to get the x by itself on the left?
Add over.
We need to add 1 for sure, and then what would we do?
Divide.
Divide by 3. So let me show you how I would do this in your calculator. So go ahead and type in math up, and type in your log base 7 of 21. And then go ahead and hit enter and get that ugly decimal, about 1.564575034. Math up to log base.
Math alpha now.
And now, what did you say we'd have to do next in algebra 1? Add 1. So in your calculator, just hit, now keep this on your screen and just hit plus 1. And then hit enter again. So it'll take the answer you just got, plus 1. And then once this 1 is canceled out, so we add the 1 over, what do I now need to do to get x by itself? Divide by 3. So as long as you keep it in your calculator, just hit divided by 3. It'll take the previous answer, divide it by 3. And that gives you 0.8549. Now this is technically an inequality, so when you write your answer, write x is greater than or equal to 0.8549. That means all numbers greater than or equal to 0.8549 would satisfy that greater than or equal to sign.
And math, he's not expecting much more work than that.
Nope.
Correct.
Just get x by itself. All right, let's go to example G. Example G. Once again, get the exponential by itself. So I need to add 7. So we get 9. Now E is the base. That's what I need to get by itself. So how do I get rid of the 5 in the front? Yeah, that's 5 times E, so I need to divide both sides by 5. So E to the negative x equals 9/5. Now just keep it as a fraction. We're going to throw it all into our calculator in a minute anyways. Now, can I rewrite 9/5 with the base of E? No. So we need to log both sides. We need to use that property, but we have a special log that cancels out E. What is it? Natural log. So this is the scenario in which you would ln, you'd natural log both sides. So the natural log of E cancels. Now this is a negative x, so there is a negative x left. equals, now don't forget to write the natural log of 9/5 on the right. Now x is not quite by itself yet. What's the last thing I need to do? Yeah, I need to get rid of that negative, so divide both sides by -1. That's just going to flip your signs. So my final answer would be negative natural log of 9/5. Once again, on a multiple choice test, that might be it. Or you can throw that into your calculator. There is an ln button. So negative natural log of 9 divided by 5, 9/5, comes out to about negative 0.5878. It needs to be in front of the natural log. That's different than the natural log of negative 9/5. All right, the last thing we need to do today is examples 1 and 2 down at the bottom. Just like we did a second ago, we need to get the exponential by itself. So I'm going to subtract over 1. So obviously that can be combined with the 2, the constant of that quadratic on the right. So we get e to the 1/2 y minus 3 equals x squared minus 4x plus 1. Okay, now how do I cancel out e and kind of get that exponent down to ground level? ln. Now this is the weird part. So natural log the left side, that cancels the e, but you also need to natural log the right side, which means you need to put the whole right side in parentheses. It's not like the last examples where we had where it's just like a number, like natural log of 9, you can throw it into your calculator. There's variables there. So you need to put the whole right side in parentheses and natural log the whole side. Bless you. So that gives us 1/2 y minus 3 equals the natural log of the whole side. Now, typically we would see a quadratic and we would factor it, right? Which is a good idea. You should always try that. But are there any factors of 1 that add up to -4? No, so that quadratic doesn't factor anyways, even if you tried. So just leave it. And now we just need to finish solving for y. The directions say solve for y. So what would I do next in algebra 1 to the left side? I'd add over the 3, but this is where they're testing your ability to understand algebra. Can I come over here and add 3 to this 1?
No.
No. That 1 is being natural log. That 1 is now a really ugly decimal. Okay? So we cannot do that. So what we're going to do, we're just going to write the entire right side in parentheses still, but then we're just going to tack on a +3 out back. So we're doing like a little spring cleaning here. We're just kicking everything to the right side. Don't care what it looks like. Go over there. Stay out of my way. I'm trying to get y by itself. And then the last step, how do I cancel out 1/2? How many halves do I need for a whole? 2. So I would multiply both sides by 2. Now once again, you have to multiply the whole right side by 2. So put parentheses around the whole right side and multiply it by 2. So cancel. That gives us 2 times the natural log of x squared minus 4x plus 1, and then a +3 added, close your parentheses.
Wow.
Now that is technically your answer. They said solve for y, and we did. And I can't combine any of those really, because there's x's there, the natural log of those x's, we don't know what those x's are. There is one thing you can do. Technically, you could go ahead and distribute the 2. So you could do 2 natural log of, minus 2 natural log of all of this, and then distribute the 2 to the other term. So that's another option, but you don't have to do that green step. It doesn't say anything about simplifying. It just says solve for y. So once you get everything kicked over to the other side, you're good to go. Yeah.
Why'd you multiply by 2 and not 1/2?
Do what?
Why'd you multiply by 2 and not
1/2 times 1/2 is 1/4. That doesn't cancel out. So the way we cancel out a fraction is we multiply it by its reciprocal, and 2 halves is a whole. That's 1 that